Hello everyone and welcome to our lab tutorial here. In this lab we'll be mainly focusing on the looping statements. We have three different statements or three different kind of loops that we will discuss throughout this activity. Let me just prompt you to to these loops here. So first of all we'll be talking and learning about the practical side actually of the loops here. By the way, in general, let me just put you this point is that we have already studied the theory part in the loop, and it's been already reached out to you and communicated with you to you throughout the the previous recording the theory, and you can reach this even in the textbook, our textbook. But in this, in this explanation, we will not be duplicating our the theory details here, but rather we will be just handling coding immediately about each of the loops here. So first of all, we'll talk about some examples how to write a while loop, and then coming to the do while loop. Also, it has its own style actually, and then we go for the for loop, and then finally we will be discussing and showing some examples of how to write and create nested loops. All right, so there are two subpoints here that I would like you to to focus on. Um, the first one is regarding the input validation using while loop. That actually not necessarily to be in a while loop, but this is actually most commonly used with while loop. So how to allow the user to validate his result in case of the user is entering a wrong input for a certain variable that we are not expecting to get that value. So we can create what we call input validation, and then we have another point here, not again as I mentioned, not necessarily to be implemented under for, but can be under any of the loops. But here we will just practice it under for loop. It is called keep running total. So it is like a variable that has been accumulatively being increased by having itself, the value of itself, added to another value. It could be like the counter, could be another value, depends on the the formula. Okay, so without the further ado, let me just show you show you the activities that we're going through here. So I will be using this handout for our activity, and I believe that you already have a copy of it. Maybe like like an initial copy of it. I have already modified in some parts here. I will just let you know about. I will send you that copy. Soon after the recording of this video. All right. All right, so enough of introduction, and let's just move to, the first loop. Here, the while loop. So before that, we should know that any loop doesn't matter whether while, whether do while loop, or for loop. It has to have something called counters here, and we have discussed this. We have been discussing the increment or decrement of the counters. Like let's say, for example, here num plus equal 1 and num minus equal 1. We can represent them both in another way, like num plus plus or num minus minus. So num here, it's a variable name that it should have a definition before it's being used here. Okay, so in this case it's n, for example, or it could be like a double any numerical variable here. Same for the other one. So this is another, this is the way how we add one to the value itself. If we want the value itself to be added with one, then we use that style. This style is very famous, again, as I told you. It is very famous when we create counters, when we use the counters in the loop. Okay, so we already understood, understand that, this point. So the other point here is that there is a difference between like placing the sign, the operator, the plus operator or the minus operator to be either before or after. It has a meaning here, and it has a different, it indicates or impacts the value of num in a different way. The first one here, as I mentioned to you, here is that we add one to the value here, and then we return the value of num, meaning that if num, for example, here was, if let's say num here was, let me just use this space here to write u. This was explained actually in the theory. I'm just refreshing with you. If like num equal to 1, roughly, I'm just writing that. So by writing plus plus num, by C out here, actually, to say, if we see out num plus plus num, this will indicate that now num will equal to 2, or this will actually place, it prints or displays 2. Why? It is because we have added 1 before we return the value. We have added 1 to the num and then we return the value. What if we have the C out here and we have num plus plus here. So this will return still, this will display 1. It displays 1 here. Why is that? It's because we have already, like in the first place, we printed the value of num, which is 1 in the first place, and then we added 1 to it. So the next value here, if we want to read like n, for example, y equal to num, then here y, of course, will equal to 2, because we have already, like after we printing the value here, we have added 1 to it. So in any place after this statement, num will equal to 1 in anywhere, unless we have modified it in somehow. All right. So this is like the this is the like the essence of and the tricks of having the operators to be plus or minus. And by the same way, again, as I'm saying, so plus plus and plus plus mechanisms and the way how we deal with the plus plus, the increment, it is the same way as we deal with the decrement. This should be clear to you. So you can take this example and review it for you. So here let's talk about the flowchart of the while loop. And again, we have already explained this, but we are just going to roughly go to that before we go to our programming and our first example. Okay, so it starts by an expression, so meaning that we first evaluate. As you remember, it is a post evaluation, meaning that the expression has to come in the first place. Like the condition has to come in the first place. Then, according to the condition here, as you are reading, then we execute a statement. So if the expression was true, then the statement, whatever body of the like the body of the while loop here, it will be executed. So statement here, it could be one statement, two statements, or like more than that. If we have more than one statement, don't forget to add curly brackets here. Okay, so if we have more than one statement, we don't forget the curly brackets here. And then after finishing the execution of the statements, it turns again into the loop. And of course, we need to we need to evaluate again if the expression is still valid or not. Until the expression turns to be false, then the body of the loop will be terminated. Like the execution on the body will be terminated, and the rest of the code outside the loop will be executed. All right. So this is just an example that has been taken from the textbook, as you can see here. So the simplest way, let me just bring it up here to you. Now it's just because we are practicing, so we will just write a simple example in order to clarify the idea. So let's just start by identifying the integer that is actually int x here, as you can see. So int num equal to 0, and this is the initial value of num here. So and then here, so we type our while loop. We type the while loop in here. The while keyword here, and then this is our condition. The condition here states that num should be if num is less than or equal to, for example, 5. Of course, open and close brackets, and here comes the body of the loop. All right. So and there you can write C out, for example, hi, and you want to add it, you want to have a little space after it in order to allow the other repetitions to not to be stick to each other. So uh, so by this here, if you can, if we run the code here, you'll notice there is one thing here. Let me just run the code and see how how's it going to perform. See, an endless number of high coming into the end. So let me just break this, because this is actually useless here. So here we are actually left with one simple thing to say. So it is that we need to have we need to have the counter to be updated here. So if we have that, I mean, like this is the counter here as we can define. So let me just hint it as this is the counter. And remember this, as we have explained in theory class, is that the counter usually used to be put in the leftmost side of the evaluation here. So the leftmost side here is the counter that we are increasing, and then the rightmost side here, it happened to be the I mean, like the controller, or like the maximum number of loops, or like the maximum value that the loop will terminate at. So normally I mean, like the rightmost value here either to be a fixed value as a literal like this, and it's actually used to be a numerical value. We cannot like write it as a string or character value, of course, because like comparisons are not, I mean, are not valid between, I mean, like characters um, or string, especially when, I mean, like particularly when we talk about greater than or equal, greater than or less than. All right, so you can actually extract, I mean, like put it like this as a literal, or you can initiate it, I mean, like extract it from a value, and the value here is called control. Here, the variable name here is control, for example. You can just use any value you want, any variable name you want here, control. But I'm just, for this example, I have just picked up I have just picked up that I mean, like this kind of name. All right, so here, if num 0 is less than or equal to control, yes it is, so this condition will be satisfied. And here, as I told you, we are left with one important thing, is that we need to update the value of num. So here we can write it. I mean, like, how can we update that? Let me just hint that, I mean, like comment that in a code. We need to update the value of num to make the loop endless, to make the loop finite, to say, not infinite. Because just now what we have in the last run, as you can notice here, this is a kind of an endless loop, or like an infinite loop. Okay, that it doesn't actually end as long as the loop is running on. Why? It is because each time there is no update. It is actually 0 will be always less than or equal to 5. So this condition will be true all the time without any update. So updating the value here, um, num plus plus, this is the update, this is how we update it. So num plus plus here, it will make that value be updated and getting nearer to the value that's actually extracted from that variable here, which is 5 here. So like iteration by iteration, so num is getting greater and greater, I mean like bigger and bigger, until it actually equals to that control. And this is the last loop here. I mean, like the last loop here, it is when the number equal to 5, because we have equalization here. Then that's the last loop. Then I mean, like updating this value more makes it 6, so 6 will not actually bring this condition to be true, so the loop here will be terminated. Okay, so let's just end up this I mean, like this console, and then run it again. Okay, yes, and then I will just hit run again, and here you go. So hi. So have a number of 6 times being printed. Why? It's because we are starting from 0, and then 5 is still included, I mean, like in the loop. All right, so this is the I mean, like this is a very simple, kind of loop. And like you can see, let me just notify you that whatever, like after finishing, and like after the loop exits here, of course, any kind of code here could be cout, could be like int x equal to 0, to I mean, like to 2, for example, and then int y, for example, equal to x here. And let's say, for example, you want to print out the like the value of count cout y is y, for example, here. All right, and in line, you can just have this code being running. So this code will be only running, and like this statement will be printed out after finishing the loop. So here, if you've exited that and recompile this again, so there you go. So it's because we didn't use actually um, any kind of breaking the line here. That's why you can see here everything has been printed in the same line. So if you want to make this more arranged, you can just have a C out here, C out, end line. That's it. So this will fix the issue here and bring the, like the loop to be in a correct way, as you can see here. All right. So this is it. All right. So it's very easy and very simple. This is the simplest style of loop that you may ever need to write in C++. And actually, it has a counter. Don't forget about this. This is the counter. This is the counter here, and this is the loop controller. Sometime let me just give you this, like this kind of notification here. um in a cases when we start like the like the numbers from 1, let's say, until 5, or like from 0 to 5, let's say. So how many loops here we have? If we don't have the equalization here, then if we have the equalization here, then then the number of loops will be control minus num. That will equal to 5 because, and here because we have also equalization, then we have a plus. Like we can we need to add 1 in order to get 6 number of loops. So how many loops here are actually going to iterate? It will be 5. But in some cases we don't, it's not necessary to start from like 0 or 1. Sometimes we need to start from 3. So from 3 to 5, this doesn't indicate that we have 5 loops here. It indicates actually that we have a difference. Like the number of loops here will be the difference between 3 and 5, and minding that whether or not we include the equalization. If we include the equalization, then it will be 5 minus 3 plus 1. Okay, because plus 1 meaning that we are adding 5 into the loop, so that will be 3. So starting from 3, 4, 5, and that's it. All right. So this is a very important note you need to take care of here. Well, so another usage of that kind of loop, as we are actually discussing here, and let me just bring this up to you, is that we need to, like we can use this loop of user input validation. User input validation, it means that we allow the user to we allow the user to enter a value between a certain range, or for example to enter a specific value. It could be like a numerical value, it could be like a string value or character value. If the user happen to enter a value that it's unwanted for the program, meaning that a value that we don't want it or we do not expect it, then we use a loop, a kind of we create a loop with with its body content being formed in a specific way in order to tell the user this is a wrong value, please enter the correct value we are asking. Well, let me just bring this more clearer to you. For example, if we ask the user here, imagine that we have a program, or like there's a program that asks the user to enter a value between let's say write a program to enter a value between, to allow user enter only a value between 1 to 100. Meaning that when of course here the question should indicate that you need to use using input validation. Why do we need to use input validation here? It is to control the user input. It is to monitor what kind of data the user have entered, what kind of information, or like what the values that the user is entering. And based on that, if the value is not the one that we are actually targeting here between this range, for example, then we ask the user to enter it again. The logic is very simple, and the same way here. So whenever this kind of question is being prompted here, so the first thing is that we define the variable, because there's a need for the variable that we need to define the variable that a user will use to store a value in. So here we define it as int num, and then we use again our cout to prompt the user enter a value between, for example, 1 to 100. Okay, let me just indent this a little bit, using the cin again here to allow the user to enter a value for num. So num here will store the value that the user enters. Okay, so now we compare as long as num lies outside that range, because here it's the this while loop, the purpose here it is to handle whatever is to handle wrong values that have been entered by the user. What do you mean by wrong values? Meaning that those kind of values that lies outside the range that we are defining within the question. Okay, so how to define this, how to write the condition here? It should be the way opposite. If we want the program to allow the user to enter a value, to enter a value within the range of 1 to 100, meaning that the input validation here, it is to be formed in order to have the in order to handle the cases where the value happen to be outside the range. How to represent the value that it's outside this kind of range? It is by using the OR operator, as we have learned in the previous chapters. So if num is less than 0, or of course, if you remember that we said that to use, to represent a value, to indicate a value that lies outside the range, then we use the OR operator. But if we want to indicate that the user should, we want to indicate a value should be within the range, then we use the AND operator. This should be, I think, clear to you, and you can revise that. And then num here should be greater than 100. You see, if you notice here, I'm just typing all the conditions here that makes the value outside the range here. It is yes, this is actually what I want here. It is not what I want by the program. It is what I want in order to trigger my input validation, because whatever code here will be prompted, as I told you, it will be prompted to handle the errors. To handle the wrong values that a user have entered. Okay, so here comes the input validation. How it is done? It is by writing again cout and cin. Typically, we just copy paste these two statements, but modifying the prompting message here, indicating that this is wrong value. Please, or enter a value. Enter again a value between 1 and 100. All right. So we don't want to use any kind of what we call counter here. It is because this loop will go as an endless, and this is, I think, to my opinion, this is one of the only implementations for the endless or the infinite loops. Other than that, we do not actually implement infinite loop, meaning that we can omit the counter that we have done just now. It is just to indicate that as long as the user is still entering those kind of wrong values, then this kind of endless loop will still working on. Until here we can write cout, for example, yes, this is correct value, and you may need to enter, to print that value num. All right, so end line. Okay, so let's just run this code again and see how is it going to perform. So let me just enter any kind of wrong value. I want to make that value, it's not within the asked question. So the program is asking me to enter a value between 1 and 100. I will just type -13 in response to that. So again here, this is what happened. It prompts me to that user input validation, whereby I still need to enter that correct value. Again, I'm insisting that I want to enter another value that lies outside the range. So all the values that can be outside the range here is still actually being prompted again for an endless amount of time, even -1, even. What about 0 here? Is 0 inside or outside? Guess what? It is actually outside. Why? Can you think of why? If number is less than 0 here, meaning that it is actually, 0 here happen to be within the range. Why? It's because we do not have equalization. Imagine if we have equalization here, then 0 will be not counted within the range. So here actually is much better to write 0, because the question is asking from 1 to 100, not from 0 to 100. All right. So both, both. That will be both 0, 1, and even 100 is not included. So we can actually omit this, because we want to indicate that if the user is entering, again, let's say we are entering 100 here. So yes, this is the correct value. And yes, because here the range starts from 1 and 100, all right? A value between 1 and 100. Or you can understand it like starting from any value between 1 and 100. So 1 and 100 are both included, should be included. Okay, so again, I'm just bringing your notifications here. If we have entered 1 here, then that statement will be this statement will be executed. Why? It's because this condition will be wrong. Okay, so if we imagine that we have entered 1, is 1 less than or equal 0? No. Is 1 is greater than 100? No. So false, false, or both will actually bring the like the entire evaluation to be wrong. Like to be false. All right, so this is very simple and sweet, and I think you can just find more practices in this. See this exercise, for example, write an input validation. It's for you to actually train yourself on it. It's very simple and actually imitate the same, like the same code that we have written here. To write input validation to allow the user to enter a value between a range from 10 to 25. Even there are actually further exercises that you can go through here. And this is actually a kind of a program that has been solved here. So finding the square root actually between the numbers here. So it's very easy, and you can actually handle it here. All right, so let's just go again here. So this is a kind of challenging question. I would like you to go through it, and I hope you really actually can understand. If you did that, I will actually guarantee that you will have no issue even with whatever topics that are going to be explained here. Again, for the do while loop, and then for the for loop here. All right. So talking about the do while loop, it is actually copying the same logic here, but it's just with a different syntaxes. With a different structure. Whatever loop that like the loop that we were just discussing about just now, it is called pre-evaluation loop, meaning that we need to evaluate first before we go to to the body of the loop. Like for example here, so evaluation comes first, and then based on the validation of that evaluation, whether to be true or false, then we're only and only able to run that code, like the body of the loop. But talking about the do while here, it is that we are running the statement first, and then at the end we are actually evaluating whether the expression is still correct, or whether the expression is still true, or still true, or has been turned to false. And we don't need to forget this sign. This is the only kind of condition that has a semicolon, right after it. All right. So we need not to forget that we have a semicolon here. For the while loop, we do not have this kind of semicolon here. So it's easy to handle this. And even if you go to the flow chart here, this is the way opposite. So instead of having the statements being executed after, after the expression, it is just expressed, or it is just being executed and prior to the loop in case of the expression is being true. Unless the expression is false, then the loop ends up. All right, so let me just, this is an example in order to count for the average for 3 courses. So I will just simply copy paste that in order to show you in action how is it going to be performed. Let me just replace it by that code, and then this is it. All right, so program here is asking is allowing the user to enter to enter scores for 3 different courses. Okay, for 3 courses or 3 different scores. Could be for 3 courses, could be for 3 games, whatever it is. But the idea here, it is to allow the user to calculate the average for only 3 times. How to handle this, how to control the average being calculated for a specific number of times? It is by using the do while loop here, as you can see. All right, so the program starts by defining the variables as we know all, and then also including that average variable. And then we also define here another variable called count, because this is the counter that we are handling. Then we prompting the user, we allow the user, you have 3 chances in order to enter. And then we start a do loop. So inside the do loop here, this is the part that actually will iterate over time, meaning that whatever statements here will be printed about 3 times. Okay, starting from 0 to 2, 0, 1, and 2 times. So cout enter the score, and then the user will enter the different values, or values for different scores that will be stored in 3 different variables. And then here average is being calculated, as you can see here, divided by the number of courses or the number of scores. And then we display the value of average and we increase the counter. Here we can just simply add that, yeah, so the number of counts here is actually counting, so that this count here is increasing nearer to get, to be uh, less than or like equal to 3. And when the counter here is equal to 3, then this loop will be terminating. Okay, let's just run that code and see. All right, so you have three chances. Enter three scores and their average. Let me just enter 12, or whatever actually values. I do not want to get any range of that. Okay, so here I'm having I'm having a first average here. Of course, that should be 13 because 13 is the middle of both values. Let me write 24, make it a little bit more sophisticated. 24, 20 again, 25, and let me type 56, for example. So average here is 83. This is attempt number 2. I'm having the last attempt here, 34, 55, 54, and then 32. So score is 40. So this is it. So here, this is the end of the program. So it ends after I have 3 times attemptations of calculating the average. It is very straightforward and sweet. And I think you can also use this logic to expand more logic that you may think of that can be added into the code. And you need to know that even inside the do while loop here, or even the while loop, we can actually write any kind of code. We can actually indicate that there is an if statement here, and with some logic here inside it. And within that logic, we can actually define, like, maybe if, like, for example, the count equal to 2, then yeah, this is actually the second, or this is the middle. You still have like one last chance. Maybe you can like word the user like this. Okay, so meaning that it is just a block of code that you can define whatever logic that you like. I would like you to go through these exercises here, and especially like for this kind of exercise here, this is an exercise that it's a challenging, again I'm saying. So I would like you, those who are actually like to challenge the the programming, please like go through that, and I would really love that you can consult me, contact me, like if you have like any queries you want to get about this. These exercises are really beneficial for you, and I will even bring some of them in the assessments later on whenever you're having the assignments. All right, so talking about a new topic here, and like the last loop, which is the for loop in your scope, in your tutorial. The for loop here, it's the most commonly used loop, and it's actually one of the best looping that can be used in any programming language, not only in C++, because it actually has a high level of customization, meaning that you can control the initialization part, you can control the testing, meaning the evaluation part, and you can control and customize the update, how to the range of increment or decrement. All right, so it's written like this. So having the for keyword, open bracket and close bracket, and then we open and close curly brackets here for the body of the loop. So within the open and close brackets here, we have the scope of the for loop. All right, so it has 3 main elements or 3 main items, and separated by semicolon here. First one started by the initialization of the counter, testing the counter to be whether greater than equal, the greater than or equal, greater than or less than, or even equal to. Most likely it should be greater than or equal, or less than or equal, and even specifically to say it should be actually less than. In order to make that loop running, the initialization here, of course, because we are initializing, we should initialize it to a value that it's less than the maximum value here, and then we update that one. All right, so the steps here, when we talk about the compiler, how it handles it. So it comes first in the initialization, and then it goes to the evaluation, and then it goes to the body of the loop, not actually to the update. Remember this. So this is step number 1, 2, and 3 will be executing the body of the loop here. And then finally, after executing not only one statement, could be like a blocks of statements here, okay, and then we can update the counter here. This is the flow chart of it. It's very simple and straightforward. So first we initiate the value here, the counter here. We compare the counter or evaluate it. If true, then we execute the statements, and then finally we increment the counter. And then we do not go and assign it again to 0, but rather we just go again and compare, meaning that this part of code will be evaluated, like it will be executed one time. So in the next iteration, this is the, the starting of the compiler will be from here, whether or not this condition is true or false. Okay, so let me just write you, like a simple kind of for loop here. It is just to indicate, how simple is the for loop. So let me just start by typing for int, int what? Int could be int x equal to 0, and then separated x less than or equal to what, 10? Yeah, and here I'm just writing a very simple kind of loop, x plus plus. So I finished the for loop statement, and then here's the body of the loop. So in the body, I will just write a simple code as to display the x value of x, for example, and then I will have another like space here in order to separate the items, and just semicolon in order to make them in the same line. Well, so just running this code, it will bring me a very simple list from 0 to 10 here. All right, as expected here. You can see that this is very simple and this is very straightforward. All right, so you can even manipulate here, and like you can define like int y equal to, or int z equal to x, int z equal to, let me just add this plus equal x, for example. So this is actually, remember what do we call that? We have already taken this in our in our tutorial here, in our theory class. We call this as a keep running total plus equal x. So actually z has here to be, it should be actually initialized before it's being used, since this is a keep running total. So either we initialize it here, int, not inside the loop actually, because this is a keep running total, so int z has to be initialized here to 0. Whenever we are writing keep running total, meaning that a cumulative value here, we should actually define it outside its loop. See, whenever I have initialized it by any value, it doesn't matter to be 0 or, like to be typically 0, it could be like 1, 2, 3, anyway. So but most likely whenever we initializing a keep running total or a cumulative total, so we run it as, like we initialize it as 0, and then here we want to display x, and let me just display at the end, well, could be well, it will be like x, and then it will be displays, so that will have a, let me just start another loop. Well, I will just end line this, end line, I will just start new line here, because I'm going to enter c out z. All right, so again, I will just indent it to see how's it going, how's it looking like. All right, so this is actually to be inherited here. So end line again here. So let's just see what's the result here. Oh, that's actually unexpected, and like the arrangement actually kind of weird, but okay, fine. Well, I will just bring this like outside, or let me just either print one by one. Could be actually, it could make kind of sense when we print one by one. All right, so either one of the statements to be printed here. So 0, 1, 3, 6, 10 until 55. How? It is because this is the accumulative, like this is the keep running total. This is the kind of like total. So 1 plus 0 plus 1, z will be 1, and again, you already know the logic behind this, and we can just display that. So it means that we can actually make operations inside that for loop. All right. So this could be very simple for you. Like to handle it, you can actually like see this is another example that's been taken from the textbook to display the value. Like the value of the counter and its square number, or a square value. All right. So these are more exercises for you to like to discuss and even try. I would like you to go through through these exercises, particularly like for these kind of exercises. All right, these are like the problem-based, I mean, like case study-based exercises. Let's say, like, let me just attempt with you that kind of exercise because I like this style of exercising, and I believe that it maybe bring kind of a challenging to your programming skills. All right, so let me ask. I mean, like, read the question here. So write a program to allow a user to enter value between 1 and 100. That's fine. Okay. So a user will be entering I mean, like a value between 1 and 100. And here is the important part. Count and display the range between the value that the user have entered, whatever value within the range, until the maximum value. I hope you really get the logic of the question. Here, the logic, let's say, for example, there's a range. We assume that the user enters a good, I mean, like a correct value. We do not want to write an input validation because I do not want to make it complicated for you. All right. You can actually change, I mean, like challenge yourself in this. You can later on, after we write our code here, you can just modify the code and add your, like, the input validation, because this is even the more accurate way to answer the question here. But because I mean, like, we're talking about like a for loop here, I do not want to complicate you in the solution, and I will just write straight away, assuming that the user have entered, I mean, like a value that lies between 1 and 100 without the need of writing input validation. So I mean, like, the part here that still we need to handle is that whatever the value has been entered, let's say, for example, the user enter 55. So we need to count and display the range between the value that the user entered, which is, for example, 55, until, for example, until the maximum value. What is the maximum value here? It is 100. So 55 to 100, how many values we have here we're going to print? It will be like the minus of them. All right. So we do not need to calculate the minus of them. It is just to loop over these values, okay, and display them. So we are displaying values from the value that the user entered until the end. This is actually a kind of a very tricky and very even challenging question to say. Let me just start writing it by defining the value. So int user val. Okay, that's just any value that the user will enter. So I'll just give it a definition without any assignment. Cout, prompting the user to enter value between 1 to 100, whatever, assuming that, again, as I'm saying to you, as I told you, assuming that the user has entered a correct value without the need to write I mean, like an input validation there. Okay, so cn here, so we enter user val to read the value, and here we use our for loop here, int x. Why I didn't use user value here? It is because this is a for loop. All right, so let me just define the counter here, that it's actually x, and the value of x here, this is the trick here. The value of x should be enter to, I mean, like, assigned to 0. Should it be like that? And like, should I write it like this, to 0, and then again evaluating the value to be less than or equal to 100, and 0 x plus plus? Will this be kind of correct? And just take a look at it and think of it for a while. Actually, this kind of logic, it will just simply explain and, like, represent, or it will loop over the value of 0 until 100. Then what it has to do with that question here, what it has to do with that logic here, because here the logic is to allow the user, or like to ask that to display the values from starting from the value that the user have entered until the end. So it means that here we need to update this to be what? To be user val. This is very simple. You see, here is the trick here. The trick here comes in that we assign that the counter value here, the initialize, or the initial value for the counter x, is to be the value that the user have entered, and we compare that value. We do not compare the user val, because the user val here, it's just only a value that has been extracted, nothing more. So inside the loop we treat it as a value, but this value is being extracted from the variable that has been defined by a user, whose value is defined by the user, and then we just compare that x. So we do not compare user val, we compare instead x. All right, it's because x here, it's the counter that we have initialized, and we even accumulate, or like increment the x. So Now it's just as simple as writing that, I mean like that C out code. So the C out code here is to display X because this is what we have been asked to do. Okay, so this is a, let me just run this code here and tell you the output. Enter 34, this is it, 34, 35, 36, 37. Yeah, it's actually kind of a very interesting code, and like kind of a very interesting question. Even it has a kind of a smart logic to be implemented. And believe me, this has a lot of implementations in the real world problems that you can see in the scenarios. Maybe this is like happen to be the basic logic for like for an extending problems, but like learning it and even adding more into it. Maybe you can add a user input validation here, as I told you before initially. So allowing the user to enter like a value between 1 and 100. Let's just add add an input as an adding a user input validation. How to do that? We can do it using the while loop. All right. So while, how to do that? We have just solved this just in a while, and just several minutes before we were just actually talking about this. So if the user, that variable user val is less than 1, less than or equal, no, it's less than 1 actually supposed to be, because equalization meaning that we want 1 and 100 to be within that correct range. Less than 1 or user val is greater than 100, then we want to do what? What should we do? We need to copy paste these and allow the user to enter the value again, but don't forget actually to change the meaning of the prompting message to say that this is a wrong value here. Enter, or yeah, it's been written here, enter value again, enter again, for example, between 1 and 100, and leave the value exactly the same here. Okay, so it means that this loop will never end until the user confirms that he have entered a value that we want here. So meaning that that kind of code, it will not be executed as long as we are entering a wrong value outside the range here. Let's just test that. Okay, so let me just type -1 again. I still didn't get it. I mean, like I still didn't get out of that while loop. 190 again, 120 again here, until I write like for example 55, and there's the output. See how interesting is the programming now, and you can actually add more code and add more logic here inside. So for example here you can say that yeah, let me just maybe just I'm just trying to open your eyes, and like is that we can actually flexibly add as much as possible of the logic as long as the logic makes sense. All right, so we can actually add an if condition here, typing like if, let's say for example, x is greater than um, if x is greater than user val over 2, what does this mean? Then let's make it just equalization to bring some kind of I mean like logic here. Then this means that if C out here to be I mean to be brought up, this mean I mean here the value is the this is the middle value. This is the middle value, isn't it? Yeah, it is. So end line here, and let's just test that. All right, I will just enter a good value here that brings the like the loop here. Yeah, it is because the all right. So I know there is a problem here, because actually we are dividing. We are actually x is integer at the end, and it has to be divided. It has to store actually a value that is actually of a variable of integer. Okay, so starting here, if x equal to um, Yeah, if x equal to 100, yeah, that would be value divided by 2. Um, if x equal to the, yeah, that is divide, yeah, value divided by, no, it should be value plus value, sorry, value minus 100, or that's the one, yeah, it should be 100 minus value. You see what I'm trying to do? What I'm trying to do here is that I'm trying to get the medium, the middle of the, I mean, like of the loop, divided by 2. All, of course, should be under user val here, not value. Okay, so all should be under, if x equal to, okay, so we can actually make this simple. And actually, I don't prefer this kind of conditioning or like evaluation here. So it's much better to initialize, I mean, like to define a variable z and assign z to be to be the result of that formula here. All right. So that will actually bring more sense. And here we don't need to write that full equation. Instead, we write z. So if, let's say, for example, here the value was the maximum amount minus the universe. This is actually to bring the medium value. This is to bring the middle point, to define the middle point. Okay, so and z here. So that will be, and that will actually store, of course. However, however, the value here will be in some cases in fractions, but at the end it will store it as a, as a integer value to say. Okay, so let's just this is the middle value, and we want to print that z also because we want to see what is the middle value here. Let me just enter the good value here. Okay, so again we're still not in. If x equal to z, yeah, then print me that. This is the middle value. It is supposed to print out. There should be actually some error here, or maybe the logic is not actually getting. We didn't get actually the good logic of that. Okay, let's try to define this in the beginning. It might work. So equal to 0, and then here we just type it as z. Let's just try that again. $55. I'm just insisting on that number. Well, it seems that the logic may not work. But anyway, like I was attempting to to print or to identify the middle value between the range here. So the middle value is as simple as this. It's supposed to be as simple as um like the starting like the endpoint minus the the whatever value the user enter. Why not we use x here? Okay, so yeah, well, let's just use x and see how it works. X equal to z. X equal to z. So for that. Okay, so I can identify, I can detect the problem here, and I think you can learn from this kind of situation. If you want to detect what is going wrong here, why it's not actually showing up, so you can do this. Actually, I'm just, that's why programming is really fun and it's really kind of interesting. Why? It's because you see, even me myself, like whenever I'm facing any any question or any issue, it is just learning by trying and discovering. Like you can discover your own this is actually, there's nothing to do with the syntax error. Everything is correct in terms of syntax. We are talking about the logic here. So how to bring the logic that can explain the the description that we are actually about to do. So here I can print z and see what's going on here. Here I have defined z. It's already defined in the beginning, and it has its own value. Okay, so that should, okay, so this is it. So divided by 2. All right. Okay. Okay, so see out z here. That should actually bring something. Oh, yeah, yeah. I've just identified what is that. Um, z is here, and then the value of z should be here, and then I should end line the code here again. Okay, so this will make the code even more clear. 55, z is 9, z is 1 until z is coming to, 0. Okay, so z here is printing. There's no problem with that. Okay, so then if x equal to z, x will never be equal to z in this case actually, but yeah, this is the logic now. So 55 again, and x here, because x here is starting from 55, so x will equal to 55. Yeah, it will never equal to, it will never actually yeah, now I just understand the situation here. It is because you're dividing that, so x will never actually come to be equal to the division. Why? It's because from this is actually a counter and this is a value, so we cannot actually display them both. We cannot evaluate them both. This is a counter and this is a value. A counter meaning that this value starts from 55 and increasing. It starts from 50. Starts from a fixed value, and then this actually a counter that's actually increasing. So I believe that this kind of logic may not work. So well, fine. It's just let me just delete this in order to not to confuse you with that. I was just trying to implement some code. Implementing some idea, but actually the logic doesn't work here. Okay, so again, as I'm telling you, I'm really emphasizing that you try to explore the code, whatever code you are trying to handle, explore it, and explore it in the way that makes you really learn even beyond whatever you are actually being studying. Okay, so well, this is it. So let's just make it as simple as this and go with the so that whatever value could be like 95, for example. So this is it. So 95, 96, 97, and continuing. Okay, so all right, so we have already achieved whatever the question is asking us to do, whatever the time that we spend. And excuse me for that time that I have been expending. Actually, I was trying to bring up more ideas into the questions, and in a way to show you that actually programming is really fun, and it can actually have a lot of interesting things that even the expertise and even those who are actually being in a high level of experience in the programming, they still need to learn, they still need to learn to think of the questions. Why? It's because the logic. It's because these kind of questions are contained a lot of logic, and the logic, of course, it is not something that we can memorize it and that's it. So it comes like if the as long as we have different issues and problems to say, like this problem, we may need to think and rethink of how to write this logic. All right, so moving to the last point here in our tutorial, that is about the nested loop. Nested loop is just as simple as that double looping. So a loop inside another loop. So we have the first loop, it is called the outer loop, and the second loop is called the inner loop. We have already taken this in the theory, and here in the practice, I will just show you a simple example. You just take a look at that example by yourself, and try to understand what is what is it about to to solve. Here it's just about calculating the average for for two students. So two students, each student has three courses. Then the students is going to be prompted to enter the three scores for the courses and then calculate the average of it. All right, but I will just take you into more simpler example. And let's say that you're being asked to to write code that imitates or that takes the following this output here at the end by displaying a. So any one of you can actually think of it like, okay, so this is a very kind of a simple code. So why do I need to write a code? To write a for loop for it. Like I can write a like this, a. That would be as simple as that, and then simply write end line and then copy paste that. How many times do you want me to copy paste it to you? Okay, one, two, three times, and there you go. So this is the code. End of the story. So all right. So imagine. Well, fine. I was telling you to write, because see that's why I'm just giving this as an example. But this kind of pattern can be extended up to the point. If I told you, can you please write me like a table of like items, like copy a table of items whereby the items happen to be in 10 times in that row. Extending on over the row of 10 times. Like here you have hundreds, 100 item, and then here even displaying these 100 items again and again and again. So what you will do here? So in this case, of course, you'll be actually having a lot of headache trying to retype again the same logic here. So trying to retype the same pattern here. So as a way out of that, we can use what we call a nested loop here. Okay, so imagine if you want to produce this kind of pattern. That will be actually very headache. So you need to count one by one, 1, 2, 3, 4, 5, and this is actually very kind of tedious and nonsense to say somehow. All right, so that's why actually I'm just taking this example as a simple example to start. For scenarios like this scenario. All right, so let's just again go back to our example. Let's just delete that kind of code. Actually, we want here to use the uh, nested for loop. So nested for, it's just simply as a simple for loop. All right, and you just take this note for for your information. When we say nested loop, it doesn't mean that it's actually only for inside for loop. While it actually means it could be like another for, it could be a for loop that it has another while loop. It could be while inside while loop. It could be like do while inside do while loop. But let me tell you this, the most famous style of writing nested loops is in number one happens to be between two different, two for loops inside one inside each other. This is the most famous one actually that you can see happening. Um, all right, so well, the second thing, it actually can be used in the while loop, but here we will be using in the for loop. So int x, let me just define this as to 0, int x to 1. I do not want to use 0 here. Int x to 1, x is less than or equal to how much do we want it to be? How many columns here, how many rows, sorry, here. So here we start by the number of rows. So number of rows here starting to be 3. So 3 and then x plus plus. This is the first loop. And then in the second loop we write for loop int y less than or equal to 5, I guess, and then y plus plus. And this is as simple as writing a a. So we want a and then with a space to indicate that. All right, so is this done? All right, seems that this is done. Okay, but let me just remind you, even though we have only one statement, we still need to use the curly brackets here. What do you think? If I run this command, should I take, should I get this pattern? Let's see. Those who guess yes, then you can see now. Well, so it's something different. Why? What's going on? However, we have two different loops here. Well, this is not enough. Let me tell you why. It is because in this case, everything has been written in the same line because we do not have any line separators here. We do not have any line separators. We do not have something like end line here to say the tag that we have taken before. So how do we accommodate this? Can we type end line here and then start the like the coding, start the compilation? No, it will bring it the way opposite. Instead of having it in one row, we'll be having it in different rows here. All right, then, so what could be the wrong here? So neither this one nor having that, like without anything works. So just take a look at that. So it seems that here after each iteration, um, after each single item for the number of the for the x, a complete set of y, a complete set of iterations over y happens. So 1, 2, 3, 4. This is for example. Let's just accommodate to like cope with that question. All right. So 4a's will be printed out. So it means that it seems that after 4a is printed out, then we need to break the line here. So how to break the line here? It's just by typing after that loop, after each loop, because this is the inner loop. And the inner loop, as we know, it will be executed more than the outer loop. You just refer to the notes of the theory and review this to like to get the theory and the notes. How can we write like how both nested loops can be formed together? So end line, this will solve the issue. Why we are doing this here? It's because after each loop we are actually exiting, like exiting the current line into a new line. So in this case, yes, we are able to have it like this, as you can see. All right. So imagine, if I type this here. I'm just trying to actually I'm trying to find the different like possible tries that can bring us here. So see, yeah, it works, but it leaves us one empty line. Why? It's because before we enter that loop, we need to execute this, and this is actually a new line, but this is not actually the sample that we are looking for, though it has the same pattern here. But if the pattern has one empty line, and most likely we are not actually asking you to have that kind of pattern, then this should be the case here. All right. So this is actually the example here. Let me just challenge you more, and can you please print that out? So here, okay, I think you should consider B before A, because A here, if you count these, you'll find these 8, and here 6, 4, and then 2. So meaning that the decrements here happen by 2. And this is actually a kind of a challenging question. Let me mark this as a challenging question for those who are really facing the challenge. This one is it's kind of easy actually to solve, because here the decrement will be like whatever counter will be minus minus. All right. So you can just go through it, and if you have any questions, just let me know about that. All right. So also go about that. This is actually kind of a use case question, that you have an information of these users, you want to print them out. So note that here um, um, we have a user from the IS department here, and then yeah, that's the problem here. Let me just bring this. Yeah, now it's more clear. Yeah, we have two staff in the IS department, and the other two staff in the accounting department. So we need to loop over the different number of departments, and loop over the different number of users in the department, and display every single details about them, or like display their names following the loop, following the question here, to enter the related information about the employees and display them. So try your best to do that, and I'll be actually happy to see some solutions, particularly for this kind of questions, even like more important than than these questions. But still, actually, these kind of questions will still actually scratch. You'll need to scratch your head sometimes. Like to find a solution, especially for this. Like kind of decrementing by 2, not actually a simple one. Well, I hope this has been informative for you, and this is the end of our tutorial now, and I will see you hopefully in another tutorial. Thank you for watching, and see you later.